Share the screen. All right, so we're getting near the end, folks, as you know. We only have 2.5 weeks left. Okay, so the test, you should have gotten your test score over the weekend, and I also sent the exam answers over Canvas announcements. So if you want to go over the test, it is there. And remember, you have the option of dropping one test. So if you do poorly on one test, or if you miss the test, if you miss a test, that can be the one that you drop. So that's always an option. Okay. So let's see, we are down to just our last test. So we're very, very good time-wise. All we have left is one last chapter. We're not even doing all of it. So 6.2, 3, 4, and 7. The focus seems to be awfully bad now. Let me try to adjust this. A little bit better. Whoops. I lost that. So let me see if I can get it back. Okay. Here we go. Okay, 4 sections left. We have 2.5 weeks. So this week is short, as you know. So Monday, Tuesday, Wednesday, and then we're 2 days off for Thanksgiving. Then after that, 2 weeks. Let's go ahead and aim for the last test being Thursday, December 10th, so I can have 1 day of review for the final. Okay. Yeah, in case you didn't catch it, this last exam there were only 9 questions. So pretend there was a bogus question number 10, and everybody got 10 points on it. And again, the language should be you got 10 points provided you submitted a legitimate exam on time with the homework on time. So in other words, if you skip the test or if you didn't turn in the homework, you don't get the 10 points. It's only for those who took the test and turned it in on time and the homework was turned in on time. So that's how I did that. Okay, so for now, let's plan on the last test Thursday. So Friday will be review. Now, you say, how do I study for the final exam? The best way to study for the final is the previous exams. Okay, so I can take this entire day on Friday for questions and answers, preferably about the previous exams. That's the best way to study. So I will draw questions from the previous exams for the final exam. So, I mean, it wouldn't be that bad an idea to start reviewing for the final now. You already have 5 out of the 6 tests. So maybe now the next 3 weeks, casually start reviewing the old material, or more accurately, the old exams for the final exam. Okay. So Thursday the 10th, Friday will be a question and answer. Again, I'm not promising I'll get you back the tests by Friday. That's too quick of a turnaround, but I usually have it done by the weekend. Okay, but I'll try to have the video for you so you can watch the answers, because the very next Monday is our final exam already. Again, please notice the final exam time is 8:10, not 9:10, 8:10 to 10:40. So if you start at 9:10, I'll let you, but I'm stopping at 10:40. You have to submit the final exam by 10:40. For the final exam, there's no homework to turn in. You just turn in the final exam, and then we're done. And that's basically it. Okay? So that's the way that's going to work. So I think we've got plenty of time. I'll give you an introduction as to what we're learning, 6.2, 6.3, 6.4, and 6.7. So a lot of that time will be taken up today, I guess. Okay? So even now, prepare for the final by going back over the previous exams. Okay, so I would say don't go back over, quote unquote, everything. That's too much. Just go over the previous exams. And again, for cheat sheets, for the final exam, just bring all the previous cheat sheets. Okay? So whereas I say you can have 1 cheat sheet, for the final exam, you should be allowed 6. And the easiest thing to do is just take the 6. Well, you have 5 right now. You're developing the 6. But if you have all 6 of those, just use the same thing. If you say, well, I lost it, or I threw it away, or whatever, just reconstruct it, make it again. You don't have to use the very same one. You can add to it. You might say, well, I wish I had put this on the formula sheet. Then, yeah, go ahead and put it in now. You're allowed to do that for the final exam. So you can bring all the previous, you have your test 1, test 2, test 3, test 4, test 5 formula sheets right now, and you're making the 6th one as we go along. Just have all of those for the final exam. Okay? And final exam would just be like the other exam, only you get the whole 2.5 hours for the final, and you don't have to submit any homework. So, but please notice a starting time of 8:10 for that 1 day, Monday, December 14th, and I'll close the session, the Zoom session at 10:40. Okay. All right. Okay, so what are we doing here? And by the way, for this week, since we're only going until Wednesday, your quiz will be on Wednesday. Yes, I'm still giving you a quiz. But look at how much time you have to turn in a quiz, right? You got all of Wednesday, and then Thursday, Friday, Saturday, Sunday, Monday, right? So you have plenty of time to do it. Okay. I always recommend that a lot of you do this, just finish it, get it over with, right? I don't want you to ruin your Thanksgiving holiday because of the quiz, right? It's hopefully not that hard. Just finish it, get it done, and then it's over and done with. But yeah, you can turn it in on Monday, 11:30, the usual, at 9:10 a.m. If those of you want to turn it in the last minute, you're still allowed to do that. Okay? Or if you want to do it, Thanksgiving Day or Black Friday or any of the other days, you can do that, I suppose, also. Right? Okay. All right, so first, what are we up against for this last chapter? Okay. All right, so we're doing something called conic sections. We are not doing polar coordinates. We are doing something called parametric equations. What does that mean? Okay. So the conic sections are certain shapes. Okay, so a lot of what I'm saying now is theoretical. You don't even have to write this down if you don't want to. I'm not really testing you on it. Okay, on page 319. Okay, a mathematical cone. Okay, there's actually more than one definition of a cone. Okay, one cone is like you normally think of as a cone, like an ice cream cone. Okay, and there's even a formula for that, where you just have something like this, right? And you put some ice cream on top or whatever. So this is a cone, and there's a formula for the volume. But another definition of a mathematical cone is this cone, it keeps going up forever, and it also goes down. Okay, so that's also a definition of a cone in mathematics. Okay, so the conical shape, but it doesn't stop, somewhere. Imagine it just keeps going up, 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 and there's also a branch going down. Okay, so technically that can also be called a cone. So they're both correct. So the ice cream cone, kind of a cone, where you have a set, radius and a height. That's okay. It can still be called a cone. But another definition of a mathematical cone is having it go all the way up forever and going down. Okay, so we have something that is sometimes called conic sections. Okay, if you slice the right way, you can get certain shapes. Okay, now we've already studied the circle before, but if you take a slice, if you were to slice this cone, like so maybe, you kind of see that there's a circle. Okay, it would go around a circle. Okay, now they're giving you slices from the cone. You can get a parabola if you cut like this. You see the U shape? That's a parabola. Okay, if you cut at an angle like so, you get an ellipse. That's called an ellipse. And of course, if you cut this straight across, it'd be a circle. But if you cut at an angle like that, it's going to be an ellipse. And if you cut straight down like so, that's a hyperbola. Okay. All right. Section 1, parabola. And we've already seen parabolas, the U shape. But there's going to be more than what you think, I guess. Okay. The next section is the ellipse. Okay. And the next section is a hyperbola with two branches like so. Okay, so that's sections 1, 2, and 3. So still a lot of theoretical stuff. Okay, so parabolas on page 320. Okay, you're very familiar, hopefully, with stuff like this. Okay, y equals ax squared plus bx plus c, but that's not the only type that we're going to look at. And we know how to translate, right? Like move over to 2, 1 if necessary. This thing want to switch the yellow to me. Okay, there's a very formal definition of a parabola at the bottom of 320. I'll go over this more later, but just letting you know what we're up against. So you have your curved part. Okay. And by the way, we're going to have parabolas open to the right also. You're already familiar, hopefully, with something called a vertex. We have a focus, or focal point, focus, and something called a directrix. Okay. Again, you don't really have to write it down yet. It's in the book. Okay. So a parabola has a vertex, a focus, and a directrix. We'll do a lot of that. There's also an axis of symmetry, sometimes just called an axis, right? So if I put a mirror right here, then you can see one part of the parabola reflects across the other. Okay, so we have a vertex, focus, directrix, axis of symmetry. Okay, so we will learn how to make parabolas like that and like that, open up and down. We're familiar with that, page 321. Don't worry too much now about the nitty-gritty details of what's all this other stuff. I'll get to that. Okay. Again, in general, a parabola, you can see here, has a focal point or focus, a directrix, and of course we know a vertex, and an axis of symmetry. In this case, the axis of symmetry is just the y-axis. But we're also going to have parabolas. Parabolas that open to the right. They might go down. They might also go left. Okay, so there's 4 basic types of parabolas that we're going to see. Okay, there's some more parabolas that we'll see. Like that, like that. Okay, so I'll talk a little bit more about that when we get to it. Okay, just to give you a broad picture, 6.3, we're doing the ellipse. And this is what an ellipse looks like. Okay, imagine it's a circle and you're just kind of making a bulge in one direction. Okay, so this is the ellipse. In case you're wondering, do you have to write any of this down? No, you don't have to write any of this down right now. Just tell me where we're headed. Okay, the ellipse has 2 focal points. Okay, I'll call them foci, F-O-C-I, 1 focus, 2 foci. Okay, and you don't have to write that down right now if you don't want to. Okay, and there's going to be 2 types of ellipses. One, as you can see, which bulges horizontally, and the other which bulges vertically, right? So it's like you take your circle and either stretch it horizontally or stretch it vertically. Okay, so those are 2 different types of ellipses. So that's section 2. There are equations for ellipses. You see here. You don't have to write it down now if you don't want to, but you can, or if you want to put it in your cheat sheet, you can do that. But I'll get to it in time. In 6.4 is something called a hyperbola. And there's 2 basic types of hyperbolas. On page 336. Okay, now, some terminology. This whole thing is considered one hyperbola. There's 2 branches. Okay, this is the left and right type of hyperbola, opens left and right. Both of these, they're disconnected, but they're considered the same hyperbola. So this is one hyperbola with 2 branches. It kind of goes left and right. The other type of hyperbola will go up and down, like this. Okay, again, this is considered one hyperbola. They have their corresponding equations. We'll get to them in time, but just so you know what we're up against. Okay, so there's 4 kinds of parabolas. Okay. Well, the book doesn't actually do a good job of showing you all at the same time, but I'll show you that. So there's 4 parabolas opening left, right, up, and down. Okay. We're very familiar with y equals x squared, the U-shape. Then put a negative sign, it's going upside down. But we can also go left and right. Okay, so there's 4 basic types of parabolas opening left, right, up, and down. There's 2 kinds of ellipses. Okay, bulging to the, well, bulging horizontally and bulging vertically. There's 2 types of hyperbolas. Yeah, the left and right type and up and down type. Okay, again, these are considered one hyperbola. That's one hyperbola. That's one hyperbola. Okay, then in section 7, we're skipping 6.5. We're skipping 6.6. 6.7 is something called parametric equations. That's different, but you'll need to learn something about parametric equations when you guys take calculus. Okay. What happens is that you don't have an equation with x and y, but they're both related to a third variable, let's say t. T naturally might stand for time. So here's an example of parametric equation. Okay, they don't give me x and y, but are x and y related? Yes, x and y are related because they're both related to t. So x is equal to blah, blah, blah. Y is equal to blah, blah, blah. So x is a function of t. Y is a function of t. Okay. What ends up happening is you can make a table of t, x, and y. So you know how we normally make a table with x and y, right? Now we have t, x, and y. Okay? So because of this equation, right, you can give me values of t, which might stand for time, and figure out the x, right? If you plug in these values of t, you can certainly figure out the x. Then you can plug in the values of t and get the values of y. Okay? And then just plot the usual x versus y. Just forget about t. Now you just plot x versus y, which is what they did over there. Okay? The reason why I gave you all this is just a little foretaste of what the rest of the semester is. Okay, so all the rest of our Math 222 are all of that stuff. Okay, so we have from now until the last test on Thursday, whatever we said, to do the parabola, the ellipse, the hyperbola, and these parametric equations. Okay, now, of course, that's not all there is to it, but you can get a feel of what we're up against. Okay. All right, so I'm going to start you off on the parabola now. So here's the parabola, and let me check something real quickly. Stopping the share. Yes, I am recording, in case I forgot to record. Okay, introduction to the parabola. Okay, a parabola is a set of points equidistant, that means same distance, from a point called a focus, I'll call it F, and a line called the directrix, call it D. Okay, so how do you get a parabola? There's a point called the focus. There's a line called the directrix. Okay, so you want all the points that are the same distance, equidistant, away from the focus and the directrix. Okay, let's take the vertex that we know. Vertex is here. That means the distance from here to here is the same as the distance from here to here. And I'm using the high school geometry type of notation. You guys remember this from high school geometry? That we put 1 mark, that means these are the same length, and 2 marks means these are the same, and 3 marks means these are the same, right? Okay. So if this point's in a parabola, the distance from here to here matches the distance from here to here. And likewise, I got 3 marks here, 3 marks here. The distance from this point to the focus is the same as the distance, the straight down distance to the directrix. So if you have a point on a parabola way up here somewhere, right? Then this point distance to focus matches the distance straight down to the directrix. Okay? So in other words, the distance from any point x comma y from that point to either the focus and the directrix are equal. Okay? Please notice the directrix is a line. It's either going to be a horizontal line or a vertical line. Okay? And we already know horizontal lines look like y equals something. Vertical lines look like x equals something. Okay? And I'll show you all of that right now. Okay, so you have a focus and a directrix, and I will show you a little bit more of what the text has, because the text does it way better than I could. Okay, page 320. A parabola is a set of points in a plane that are equidistant from a given point called the focal point, I will say focus, and a given line called the directrix that does not contain the focal point. Okay, so here's that same picture. That 1 mark and 1 mark, this distance and this distance are the same if you have a point on the parabola. Okay. The point of intersection of the axis in the parabola is the vertex. We already know the concept of vertex. Okay. Now, we've already done many parabolas that open up and down. Now we're going to have parabolas that open left and right. Axis, think of axis of symmetry, right? It goes through the focal point and it's perpendicular to the directrix. Okay, it's your axis of symmetry. Okay, so I put a mirror right here, right? The mirror image of the top, of the blue top is the blue bottom, and so on. Okay, so same distance. So here are some other pictures. If this point is on the parabola, this distance and this distance is the same. Okay, here's a parabola which opens down. This distance and this distance are the same. Okay. Bottom of 321. Focus, directrix, this distance and this distance. is the same. Here's our familiar y equals x squared. You're saying the focus is 0, 1/4. I'll show you how to get that. And the directrix is y equals -1/4. Okay, so you've been doing a lot of y equals x squared ever since your algebra days, right? Oh yeah, y equals x squared looks like that. Hidden behind the scenes that you never considered probably until now, there was a focal point of 0, 1/4, and there was a directrix of y equals -1/4. Okay, so if I take any point on the parabola, let's take this point over here. At this point, the distance from here to here matches the distance from here straight down to the directrix. Okay, that's what's happening. Now, here are the 4 parabolas to concern yourself with. And again, if you want to put these on your cheat sheet, you may. Parabola opening up, which we're familiar with. Down, which we're familiar with. Less familiar, opening to the right, opening to the left. Okay. So I'll discuss each of these in turn. Notice for these basic examples, the vertex is always at the origin. Vertex is at the origin. Vertex is at the origin. Vertex is the origin. Vertex is the origin. Right? And you may have heard examples where if you have a parabola which opens up, the vertex is the minimum point, the lowest point, right? If your parabola opens down, the vertex is the highest point. How about going left and right? If your parabola opens to the right, then you could say this vertex is what? The leftmost point. That would be sort of like the minimum. I mean, if you turn your head 90 degrees, saying, oh yeah, that's the minimum. So in this case, that would be the leftmost point. And if you have a parabola opening to the right, the vertex is the rightmost point. All right, so now let me give you stuff that you need for each of these. In case you're wondering, I'm not going to go very far with the homework problems today, maybe not at all, but that's okay. I have to go over all this background stuff. All right, now, you could do some heavy-duty math, okay? I won't show it to you, but if you actually figure out, let's say this point over here, right? If you take the distance from there to there and set it equal to the distance from there to there and do all the heavy-duty math, I'll tell you what the formulas come out to be. Okay. All right, so parabola opening up. Here's my vertex. I'll abbreviate vertex with V. Okay, right now we're at the origin. Focus, directrix. The focus is 0, P for a parabola opening up. And these are our standard parabolas with the vertex of the origin. If the vertex is moved, we know what to do, right? Move left, right, up or down. So the vertex is at 0, vertex is 0, 0. Focus is 0, P. P units up. The directrix is y equals -P. P is the focal distance. Here's the equation. X squared equals 4py. Okay, put this on your formula sheet if you wish. Okay, so for parabola opening up, okay, by the way, the focus is always on the inside of the curve, no matter how the orientation is. So there's 4 different parabolas. Notice where the focus is. It's on the inside. Focus on the inside. Focus on the inside. Focus on the inside. So the directrix is on the outside. Okay, so I'll abbreviate focus with F. Directrix is usually abbreviated with little d. Y equals -P. By the way, again, the directrix is either going to be a horizontal line or a vertical line. Horizontal lines have the equation y equals a constant. Right? Y equals -P. In this case, y equals P. Okay. For a parabola which opens right or left, the directrix is x equals something. Okay, so I will not accept for full credit if you just say the directrix is 4. No, you have to say x equals 4 or y equals 4 or whatever. Okay, you can't just say 4. Okay, case 1, parabola opens up. Here's the equation. X squared equals 4py. The directrix is y equals -P. Focus is 0p. And if you stop and think about it, easy way to remember it is you say, okay, I know y equals x squared fits this category, right? So y equals x squared should be in this family. And here it is, x squared equals y, or y equals x squared. if y equals x squared, that means this coefficient should be 1. If 4p is 1, that means p is equal to 1/4, okay, which tells me that's where they got that picture, right, of p being 1/4. Page 221, right? Y equals x squared. P was 1/4. So I go 1/4 of a unit up, 0, 1/4. I go 1/4 of a unit down, but it's not just a point, it's an entire line. So notice the directrix, that entire line, y equals -1/4. Okay. Now it sounds kind of complicated, but if you stop and think about it, if you understand this one really well, the same rule applies for the other 3 parabolas, which open down, left, and right. You just have to make sure the focus is always on the inside of the curve, the directrix is on the outside. Okay, how about parabolas opening down? As you might guess, x squared equals -4py. A good example is y equals -x squared. Again, if p is equal to 1/4, then it'd be x squared equals -y, or y equals -x squared, opening down. Okay, so the focus, always on the inside, this time is 0, -p, which is exactly the mirror image of this one. So focus is 0, -p. The directrix is now y equals p. It's up over here. And of course, the vertex is still the origin, 0, 0. Okay. And as you might guess, if the parabola opens down, there's a negative. So again, if p is equal to 1/4, 4 times 1/4 is 1, you'd have -y equals x squared, or y equals -x squared. So that's of the type of parabola opening down. So the focus is on the inside of the curve, 0, -p. Directrix is y equals p. Okay, now, how about if the parabola opens left and right? Can you guess what would happen? These two have x squared, but not y squared. These are the reverse. They have y squared, but not x squared. It's just a role reversal. Y squared equals 4px. Y squared equals -4px. So if you see y squared equals 4px, it opens to the right. Vertex is still the origin. Focus is still on the inside. So if I go p units to the right, the focus is p, 0. I go p units to the left, the directrix is x equals -p. Again, I won't accept it if you just say -3. You have to say x equals -3 for the directrix. It's the equation of a line. Okay. Incidentally, side note, notice here, x cannot be negative, which is true, right? If you have y squared, right? If you have y squared anything, you can't have a negative value for x. And then y squared equals -4px, that parabola is going to open to the left. So this time the focus is -p0, the directrix is on the other side, x equals p. So these are the 4 types of parabolas. Okay. Again, let me review them quickly. Opening up, x squared equals 4py. P is the focal distance, or the focus. Opening up, focus is 0p, directrix y equals -p, vertex is the origin. All of these are vertexes of the origin. And you know what to do, yeah, like this down here, if you want to move it somewhere. Okay, parabola opening down, x squared equals -4py, like y equals -x squared. Okay, so the focus is 0, -p, directrix is y equals p. Vertex is still the origin. And I will abbreviate, as you can see, focus I'll call F, vertex is V. I have a need to write vertex right now because they're all 0, 0, but later on we're going to move it. Right? Well, like here, right? Vertex is -1, 2, because it got translated 1 to the left and 2 up. Okay, my directrix abbreviation is little d. Okay, opening right and left. Y squared equals 4px. Opens to the right. Positive, no negative, squared in y but not in x. Goes like that. Focus is p0. Directrix x equals -p. And finally, the parabola which opens to the left, y squared equals -4px. It opens this way. Notice the focus is always on the inside of the curve. Vertex is still the origin. Focus p units to the left would be negative p0. Directrix go p units to the right, but be careful, it's an entire line. So the directrix is x equals p. All right, so all of these four basic parabolas, okay, put it on your cheat sheet if you wish. I listed them with the vertex at the origin. That's the nicest case scenario. But we know what to do. If instead it says x plus 1 squared equals 4p y minus 2 or something like that, that's a translation of 1 to the left, 2 up. So the vertex is negative 1, 2. X is replaced with x plus 1, that's 1 unit to the left. Y is replaced by y minus 2, that's 2 up, so 1 left, 2 up. Okay, and physics application. So I'm not testing you on this, but just the whole idea of focus, right? If you have a parabola, okay, as you might guess, works two ways. Suppose you're at a focus and you emit beams of sound or beams of light or some kind of rays. Okay, wherever it bounces off from the focus, when it hits the parabola, it goes in parallel rays out this direction. It also works both ways. Okay, going backwards, if you have rays of light, let's say, or sound waves or whatever that bounce off the parabola, they're all going to bounce over to the focus. Okay, there's a physics property called angle of incidence is equal to the angle of reflection. So if you bounce off of here, if you pretend that there's like a barrier here, right, it will bounce off and hit the focus. Hence the idea of the word focus. And of course, you've probably seen parabolic dishes. Okay, some cable companies or some TV companies have a parabolic dish. Well, that's a three-dimensional version of the parabola, but the three-dimensional concept, you have a focus, right? So it works both ways. You can have rays emanating from the focus. So if you send out, whatever you're sending out, sound waves, radio waves, light waves, bounce off the parabola, and it goes in a straight line direction like that. But it also works the other way. Okay, just the idea of the word focus. Right? If you have parallel beams bouncing off the parabola, it will come to the focus. Okay? It's my understanding that your headlights on your car are parabolic. So if you have your headlight beam here, right, and you have your parabolic three-dimensional equivalent of your parabola. So when you emit, you turn on the headlights, right? Then of course the light's going to scatter in all directions. But when it bounces off the parabolic shape, it all goes straight here. And that's the way you want the light to go when you're driving, right? You don't want the light to go that way and all over. You want it to be concentrated in the direction that you're driving, hopefully, right? So if you're heading this direction, you want the light to go that way, right? You don't want it to go there and all over the place. So the parabolic reflector does that for you, where all of the rays of light will go in the same direction. Okay. And let's see. I think the book does something like that also. Yeah. Page 324, reflection property. Okay, so pretty much what I said here, right? So if you're at the focus and you emit sound or light or some other wave that emanate from it, then they're all going to come out this way, parallel, for parabolic dishes. And again, it works the other way. You could have rays coming in. If they bounce off the parabola, they're all going to come to the focus, which is the whole English word focus, right? That everything is coming in to focus. So your parabolic dishes, I suppose, have that concept, right? You can see that they have over there. Okay, we're almost out of time, and I haven't done anything. So maybe I'll just do one or two problems. We'll do more problems tomorrow, and then that'll be it. So most of the rest of the semester, I'll end early and let you ask questions since we have plenty of time. Okay, so now all you care about is how do I do the homework problem, right? Okay, so sketch the graph of the parabola, turn the vertex, focus, and directrix, and so on. Okay, so the object is make the equation look like that, or that. And by the way, what I'm giving you deviates a little bit from what the book has. The book has something which is correct, but I don't like the way they do it. So I want you to do it my way. Okay, so, and a lot of other, it's not really my way. It's a lot of other books do it so-called my way also. Okay, so things to look for is it squared in x or is it squared in y? Only one of the variables is going to be squared. It's either going to be x squared and y isn't, or it's going to be y squared and x isn't. Okay, so if x is squared but no square in y, it's either going to be up or down. Just as we already knew, like y equals x squared, y equals negative x squared, right? So clearly the other way around, if it's squared in y, y squared but no x squared, it's either going to go left or right. And how can you tell? As you can probably guess, okay, you should think y equals x squared, right? Like that. It opens up. Okay. So if you see only positives, opens up. Once you see the negative, it's going to go down. Like y equals x squared. Now, to switch the roles, you have y squared but not x. It's going to be either left or right. Okay. Which one goes to the right? Well, right is positive, right? If all you see is positives. Okay. But once you see the negative somewhere, opens left. Okay. That's pretty much all you have to do. And then you have to translate the equations that they give me, like all this. You have to force it into the form of 4p. That coefficient, make it 4p or negative 4p, as the case may be. So it's got to make it like either x squared equals 4py, x squared equals negative 4py, y squared equals 4px, y squared equals negative 4px. Okay, so maybe just for practice, let's talk about which way does the parabola open, left, right, up, or down. Okay, this should be an easy one. Y equals 2x squared. Okay, does it open left, right, up, or down? Squared in x, not in y, and only positives. So it's going to go up. Right? Just as you anticipated, you know, like y equals x squared or whatever. Okay, how about number 3? Now they wrote it funny, you have to clean it up a little, but it's squared in x, not in y, and there's a negative. So which way will this one open? It'll go down. 5. Y squared, but not x, and everything is positive. Y squared, x is not squared, everything positive, that's going to open to the right. 7. Y squared, x is not, and there's a negative. That's going to go left. Okay. And as you might guess, these are harder, so I'll have to show you tomorrow maybe how that works. Let me try to set up at least one. I've got to show you at least one problem to get you started on some of the homework. So I haven't shown you very much, but I'll just do one perhaps and then I'll quit. But maybe some of you, once you see the first one, you know how to do the rest. But if you don't, that's okay. We can do more tomorrow and Wednesday also. Okay, and by the way, in case you're wondering, yeah, Wednesday's quiz will just be on the parabola. I'll just focus on the parabola. But I might be able to sneak in some ellipse on Wednesday also. But even if I don't, we're good. Okay, number 1, y equals 2x squared. I'll just show you that, then maybe I'll stop since it's already 10:02, and I don't want to give you time to ask questions. Okay, so squared in x, not y, no negatives, so it's going to open up. Okay, so I drew a little parabola that opens up. Okay. You'll notice in my notes here, I draw a tiny little parabola that tells me, oh yeah, this one opens up, this one opens left, or whatever, right? Okay, y equals 2x squared. Now I have to force the equation to look like x squared equals 4py. So you must isolate the x squared, everything else goes on the other side. Okay, so y equals 2x squared, take half of both sides, x squared equals 1/2 y. X squared equals 1/2 y. Now I must make it look like 4py. So this 1/2 is equal to 4p. So how do I do that? Well, 4p is equal to half. Okay. So x squared equals 4py. X squared equals 4py. There's x squared, there's the y. So this 1/2 has to equal my 4p. So I do a little bit of algebra. 4p equals 1/2. Multiply both sides by 1/4. So p is equal to 1/8. Okay. So the equation in standard form is x squared equals 4 times a half. Times 4p, which is 1/8, times y. Because 4 times 1/8 is 1/2. So the focal distance, p, is equal to 1/8. All right, so here's the entire picture. Okay. So we know it opens up. So the focus is on the inside. I go 1/8 of a unit up. So this is not even to scale, but I just give myself some more elbow room. The focus is 0, 1/8. The directrix, I go 1/8 of a unit down, but don't forget it's not an entire point, it's an entire line. So the directrix is y equals -1/8. Okay. All right, so that was just one problem. That's all that I was going to show you for today. So some of you maybe know what's going on. You can get started on the homework. But if not, I'll do more of that tomorrow. Okay, so let me stop and check to see if anybody had anything in the chat. Nothing in the chat. Oh, okay. All right, so I'll take questions, but if you don't have any questions, we're done for the day, folks. I think I'm okay time-wise, and we'll see how it goes. Okay, any of you who joined late, just send me an email, and I'll get you for attendance, and that shouldn't be any problem. Okay, any questions? You can unmute yourselves and put it in the chat. Okay, we're done for the day, folks. All right, so bye. See everybody tomorrow. Bye, have a good day.